problem 23, we have 4 capacitors. We have to label each one. Let's say we have 1, 2, 3, and 4. Find the equivalent capacitance between points A and B. So we have to find the total equivalent. Okay? As you see here, between this point and this point, we can say A and D. Okay? Between this node and this node, we have 2 capacitors in series. We can say 1 and 2 are in series. Here you have, if you want to see, or if you want to know if the capacitors are in series or parallel, you have to see the nodes. Here we have one node, and here we have one node. Between the nodes, we have a series capacitors. Okay. So between 1 and 2, C1 2 equals to C1 C2 divided by C1 plus C2. You know, 1 divided by C1 2 equals to 1 C1 1 C2. So C1 times C2 equals to 15 times 3 micro times micro will be 10 minus 12 farad divided by C1 plus C2 equals to 15 plus 3 equals to 18 micro farad. Okay, so we get here 15 times 3 equals to 45 divided by 18 micro farad. This is C1 2. I can give you the answer will be equals to 2.5 microfarad. Okay, now here we can delete 1 and 2, and we have here one equivalent C1 and 2 with 2.5 microfarad. Now between A and D, we have the same voltage of C12 and C3. So as they have the same voltage, we can say C12 and C3 are parallel. So C equivalent, C12, 3, the equivalent equals to the summation of C12 plus C3 equals to 2.5 plus 6 equals to 8.5 microfarad. Okay, so we can put the equivalent of this one and this one will be between A and D will be C1, 2, 3. Now, as you see, between A and B, we have two capacitors in series. So we can say C1, 2, 3 and C4 are in series. If you want to calculate the equivalent, the total equivalent between A and B, we can say C equivalent, which is equal to C1, 2, 3, 4 equals to C1, 2, 3 times C4 divided by C1, 2, 3 plus C4. The final answer will be 5.96 microfarad. Okay, this is the C equivalent between A and B. Now I want to calculate the charge on each capacitor if delta V AB equals to 15. I have to find if delta V between A and B equals to 15. We can delete this one. Okay, anyway. Here I want to find Q on each capacitor. Look here, between A and B, we have delta V, which is equal to 15 volt. Before, we calculated the total C equivalent, 1, 2. We said C equivalent equals to 5.96 microcoulomb is connected to 15 volt as delta V equivalent. So we can calculate here Q equivalent, which is equal to C equivalent times delta V equivalent equals to 5.96 times 15 equals to 89.5 microcoulomb. Okay, from this figure here, we calculated C equivalent of this one. This one, we have C1, 2, 3. This capacitor is in series with C4. So this one C1, 2, 3, and this one is C4. C4 equals to 20 microfarad. Okay, we can say like this: delta V equivalent equals to 15 volt. Okay, this one and this one are in series. They have the same Q. Okay, here we have Q equivalent provided by delta V equals to Q1, 2, 3 equals to Q4. It's a condition in the case of a series capacitors. Okay, so we can say here Q4 equals to Q1, 2, 3 equals to 89.5 microcoulomb. We have Q4, we have C4, we can calculate delta V between this point and this point. Here we have D and here we have B. So we can say here at C4 we have Q4 equals to 89.5. We have C4 equals to 20 microfarad. So delta V 4 equals to, you know the relation, equals to Q4 divided by C4 equals to 89.5 divided by 20 equals to 4.47 volt. You know, this delta V equals to delta V 1, 2, 3 plus delta V 4. Okay? Delta V equivalent 15 is divided between delta V 1, 2, 3 equals to delta V AD. Okay? 1, 2, 3 plus delta V 4 is the condition of a series capacitors. The total delta V is divided between delta V of the first one plus delta V of the second one. So we calculated delta V4, we can calculate delta V1, 2, 3. So delta V1, 2, 3 equals to 15 minus 4.47, which is equal to 10.53 volt. Okay, here as you see, delta V1, 2, 3 equals to delta V AD. Delta V AD equals to delta V 1, 2, 3. We come here, we calculated delta V between A and D, so we have delta V through this capacitor. We have delta V, we have C, we can calculate Q. Okay, so here we take C3. Delta V through this one is the same as delta V AD, which is equal to 10.53 volt. We have C3 equals to 6 microfarad, so Q3 equals to C times delta V, okay, which is equal to 10.53 times 6. Don't forget the unit. Here we have microfarad, and this one is volt. We get Q3 equals to 63.2 microcoulomb. Okay, we calculated Q. You know here, Q equivalent here, Q equivalent is equal to, we calculated Q equivalent equal to 89.5. So here we have Q equivalent is divided between this part and this part. We calculated this part equals to 63.2, and the remained part will be on this branch. Okay, you know, here, okay, so uh, you know, 1 and 2 are in series, 1 and 2. Q1 equals to Q2. Okay, and you know, q equivalent q equivalent here is divided between q3 plus q12, because q1 equals to q2 equals to q equivalent 1 2. Okay, so we can calculate q12 q12, which is equal to q equivalent equals to 89.5 minus q3 63.2 equals to 26.3 microcoulomb. So this is q12, which is equal to q1 and q2. Like this, we calculated q1, q2, q3, and q4, and also delta V of each one.